So, this will be a tutorial on how I went about rigging the spring for this enemy character for a game that I'm currently working on. In it, I'll be walking through my process, including how to use PyMelt to speed things up. If you haven't used PyMelt, pretty much all the things I can be doing be done the same syntax as MyPython. And it should be safe to say that in this tutorial, I recommend for people who have at least intermediate Python knowledge. But I'll be walking through everything every step of the way, so you should be able to follow along regardless of skill. So, let's start out with a clean slate. First, we'll be making the actual spring by making a helix, and we're going to be messing with some of the helix attributes to make it look better. These are just some of the attributes that I messed with previously that I liked to make a nice little spring here. Yeah, I like the grid on. So, now that we have this lovely little spring, we're going to first select some vertices, because we're going to be making a curve that goes throughout the entire spring, as this will be a joint-based rig, so that it can work inside of an engine. So what I did right there was I selected the bottom vertice, and I selected the top outer vertice, and I hold shift and I double click, which selects the entire ring around the curve, which is great. It's exactly what we need. Now, we're going to make a script to make a curve along here so we don't have to manually select every single point. And that way we'll make a perfect spring curve. So, first off, since I'm going to be using PyMelt, going to import PyMel core as PM. Just gonna run that, make sure that it is imported properly. Now, first thing we need to do is we need to get the selection. So I'm going to create a variable and use the ls command. That will get whatever you have selected. And now we're going to need to loop through all of our selection, which, if you look at it, is every vertex that is from our helix shape. I'll rename it later. So let's do a for loop. First thing we're going to need to do is get the location of every single vertice as we're looping through it. So we're going to get the x form of this curve. So I'm using the shorthand here, but what this is saying is it is querying the world space transformations of this object, which happens to be one of the indices of this list. Next thing we're going to do is curves are a little finicky in Maya, so you need to create the first point of the curve and then store that value and then add to it every time. But it's pretty simple. So first, we need an if statement to see if the object being iterated through is the first version, or the first index. So we just compare it against the first index of the parent list. Next thing we do here is we actually create the curve. So make a variable. And we use the curve command to create a list, or to create the curve. Sorry. What this is doing here is this is a shorthand for point of the curve, or position actually. And what this does here is it gets a vector of whatever we have selected. But that stores in Python as a list, which this argument does not understand. So we have to break it apart and because this is stored as XYZ, we are getting the first index, the second index, and the third index. And then we need to just tell what the degree the curve will have. And since it doesn't need to be a particularly smooth curve, we are just going to use first degree. So it's not cubic. And now, if it's any other index than the first, we also need to create the curve. This is actually overriding the variable, but it doesn't matter. So this is going to be almost the exact same, except we are using the same variable because it'll be getting this curve point, and we're actually going to be reusing this part of the code as well. So we can just copy that over. For that. So that'll still be getting the next, or whatever point we have selected from our list. And now we need to use the add flag right here. Make that true. And let's test out our code. Should deselect everything just to make sure that it doesn't do anything silly. And look at that. We have a beautiful new curve. goes along the entire thing. It's got a lot of CVs, but that's fine. Since this is going to be in game engine, this curve doesn't matter at all. And it's a curve anyway, so it doesn't have a huge memory impact. Let's name this spring curve. And we'll call this one spring static mesh. Alright. So, now that we have curve, something important that we need to do is make sure that the curve is facing the right direction. So as of right now, it's going from bottom to top. And if that's what you want your spring to do, great. But for our circumstance, we want the spring's joint to be at the top and go down. So what we need to do right now is use a command called reverse curve. And this do exactly what you think it does. It reverses our curve that we've already established as a variable. And using those flags, we will reverse this curve. The name has been maintained and everything is good. Alright, so now our curve is beautiful and good, but we would like this to be inside the mesh because that's where the joints will be. So let's turn on X-ray so we can see it inside. And I already have the values that work well with this spring, which will be scaling the X and Z to 0.75. And now that's pretty much perfectly in the middle. Alright. So, now that we have this beautiful curve and this beautiful mesh, let us actually make the joints. So, first off, we're going to need to establish some variables. We're going to need a counter. Going to need an increment variable for the CVs that we'll be going through. We're going to need a list in order to store the CVs, just for easy iteration. And this is good just to have periodically throughout your code, is a clear selection. So that no code you're writing accidentally uses whatever you have selected in the viewport here. So, first off, let's get those CVs using the CV list. It's actually a fun thing that you can do in PyMel so that it will use IntelliSense with PyMel. So, CV list knows exactly what I'm talking about. And since we created this curve with PyMel, it has certain methods. So, using our curve variable, we will get the CVs of it. Just like that. We have every CV in that curve in order. Even uses the name and everything. So now we need to iterate through this list. Going to be setting up another for loop. So as we go through here, we're going to increment using the CV incrementing variable. And we're doing this so that we can modify how many joints we create. Down here, we're going to be checking to see if the incrementing variable, nope, not that one, is a multiple of 3, which effectively says for every third CV, it'll create a joint. This is a method of efficiency management so that we don't have a joint chain of 141 joints. This way it'll create a third as many, and it's still a relatively high resolution joint chain, but this method should work regardless. You could have 7, 6, if you wanted it, you could go straight 141. But for now, I used every third. And just to explain what this is right here, this is a modulus which gets the remainder of this division. So what I'm doing right here is I'm saying if the remainder equals 1, then it creates a joint. And if it doesn't, it does nothing. We'll be using our count variable to, this one's for a naming structure. Again, we're going to be using xform. We're going to be this time getting this loop's iterating. So we'll be using Q. We'll be querying that, getting world space, and the translate. Now we're going to make the joints. So we're going to make the Spring joint and use this function to create joints. Gonna name it. Gonna call this one Spring, and we're going to use this to append our count. So gonna name that, and wherever you have the % and s, it will add whatever variables you tell it to, pretty much. So here it will be saying spring wherever number count is and joint. And we're going to be setting the radius of these joints to 1. And now we're going to be moving these joints once again using the xform value that we got previously. Going to be putting that on the spring joint. And we're making an absolute position so that it doesn't try and move things relative to something else. Say the spring joint. So let's see how well this works. Yeah, look at our beautiful spring. And just like that, we have joints. Look at that. And as you can see, it's not following the curve perfectly because it's moving on every third CV. See? 1, 2, 3, 1, 2, 3. And right now we have, hold on, 47 joints. Still not a small number, but a lot better than 140. And just to show that you can use this method for considerably fewer, let's bump that up to 5. And clear those values again. And as you can see, it's still following it for every fifth joint, follows the curve decently well. I'm sure this method would work, but with a bit less resolution for the skinning that we'll be doing later. And if we decide to be silly about it and make this a full resolution joint chain, a lot simpler just to do that. There we go. There's a insanely high resolution joint chain for a spring that will be part of a character. So, not exactly recommended. Let's just undo that. Alright. Perfect. We have a lovely joint chain, and now we're going to be adding IK. Specifically an IK spline handle. Not that. So, in our rigging menu, we'll be going down here to create IK spline handle. I'll reset the tool just so that it's like everyone else's. You will not want auto parenting curve. You will not want to auto create the curve. And that's remaining unchecked. Cool. The only thing you want is the root on curve. So, what you're going to do is close that. You're going to go back here, click create IK spline handle. So first thing you do is you select the first joint, then you select the last joint. By the way, it doesn't matter that it didn't reach the end of the curve just because the number of CVs wasn't a perfect multiple of 3 is why it didn't reach the end, but that really doesn't matter. And then you select the curve, which sometimes can be a pain within the viewport, so I would just, by the way, you need to be holding shift to select the first joint, then the last joint, because you're doing it within the viewport, but inside the outliner here, you need to hold control. It's silly, but it's how they do things. So if you hold control and select the curve, then bada boom, you have this. You now have the IK spline handle going through your entire joint chain using the curve you created. Alright, so I'm going to go through 2 methods of making this into a spring. The first method is easier, but doesn't create the spring you probably want. But I'll go through it just because it can be useful, and you can use this to create a spring with a lot more controls in it, which the next method won't. First things first, we're going to create 2 joints. These will be control joints that do not need to be parented. I'm going to be closing the script editor for now. Gonna make these joints bigger than others, just so that they're easily seen. This is going to be the top control joint, and this one's going to be the bottom. And we're going to zero these bad boys out. Now that we have our joints, we're going to make some controllers. Just for simplicity's sake, we're just going to use some circles, scale it up so it's a little bit bigger. Call this one top control. Gonna move this up to the top. Snap that onto the joint so it's exactly where it needs to be. We're going to modify and freeze it. Gonna press Control D to duplicate it. Move that down to the bottom. Hold on. There we go. Now it's snapped to the bottom joint. You can snap things by holding V, by the way. V and using the translation tool. Gonna rename this to bottom control. Because as good riggers, we name everything. Alright, so then just do a simple parent constraint by selecting the curve first and then the joint. Do parent constraint there, and do the same thing for the bottom. If you press G, you'll redo the previous command you used. So I'll just press G there. You're going to smooth bind the controls to the curve. So you're going to select the controls, then the curve, go to skin, bind skin, make sure that's on selected joints. Max influence is 2, closest distance, classic linear, all that's good and dandy. And I should mention that what the IK spline handle does is it binds these joints to the curve that we created. So wherever, here, let's hide this for ease of showing. Wherever this curve goes, these joints will do their best to stay on it. So by binding this curve to these joints, our control joints, we have effectively simplified these controls. As you can see, they're moving pretty nicely. And hence why we wanted these controllers. Alright, let's show that again. And now we're going to do another skinning. We're going to be skinning the actual skin joints to this. So first let us press, if you press Shift plus, you will expand the entire hierarchy of what you have selected. So I'm going to select all of the joints from our spring joints and make sure our mesh is selected. And now we're going to go back into bind skin into the option box. And it is very important that we change the bind method to heat map. The binding method won't skin your spring exactly how you want it to. Right now it's binding. Alright, let's see. Let's turn off that. And we have a pretty nice looking spring. Oops, never froze the transforms on that one. Easy enough to do though. Go to channels, freeze, translate. There we go. Now it can be zeroed out. And it's a pretty good spring rig. Although you can see that it's not following the top perfectly. Overall, not too shabby. And as I said before, you could add more joints to this curve, but that'll make the rig more complicated, but it'll also give you more points on which to control it. So there's a give and take. Just for simplicity's sake, we are going to be removing the skin cluster off of this spring. Now I'm going into the node editor, selecting the spring curve, pressing this button to see all of its inputs and outputs, and I am deleting the skin cluster. Boom. We have a completely non-functional rig now. Beautiful. We already have our curves and joints here because they'll be using those again. And first we need to do is minimize that. Put the top controller into a group. And I'm gonna name this top control group. And we are going to center the pivot. Very important. And now we're going to add an aim constraint from this group to the bottom controller. So first off, let's go to constrain, aim. Going to make sure there is no offset, that the aim vector is going at -y and nothing else, because we are aiming from the top to the bottom, and as you can see here, y is facing up, so we want to go opposite of that. And we are making the up vector also positive y, because that is what is up to this rig. So select that, and then the bottom control, actually wait, we want this group to actually be facing the bottom control, so the bottom control will be in charge. So bottom control first, then group, you press apply, and now that will always be facing wherever the bottom control is. We're doing this so that the spring will always be facing wherever the bottom control is, because we're changing how this will work. And now we're going to be setting up a stretch. First off, we're going to need to create a curve. Gonna get rid of that. A curve that goes from the top to the bottom. So, actually, let's reuse our curve tool by opening up the script editor and getting the selection of these two objects. Sometimes the translation doesn't work as a method of getting its actual position in world space. So what we need to do is set the rotate pivot, which is much less likely to be modified. So now we have this curve here, it goes from the bottom to the top. And we need to create, I'm just going to add code in the middle here. We need to get the arc length of the curve, which will be a node on it that gets the length of the curve as well as some other information about it. So to get that, we will type in PM arc length, and you get the channel history from it too. Otherwise it won't work. For that, should probably name the curve. Alright, so now as you can see here, that got the curve info. And if we go back into our node editor, select the curve, press get input and output connections, there is now this fancy curve info node. And if you press those buttons and double click it, you can see the arc length right here, which is the curve length. Now that we have that, we can use this as a method of seeing if the spring has stretched or not, or at least if the distance between these 2 points has changed. So from the arc length, we're going to be creating a multiply divide node where we are getting the multiply divide node and setting it to divide, and connecting the arc length to the first input. As you can see, that has connected this value here, and we are going to divide it by itself, which will actually normalize the value, which is exactly what we want for the distance between joints. We select the top control joint and press this button to add it to the node hierarchy. Gonna drag it over here and connect that to its Y scale. We're going to connect the output of X to the scale of Y. We're doing that because that is a scale that goes up and down on it. So what we're doing next is to make sure that the curve is actually connected to the joint. So I'm going to select the top CV here and add a cluster to it. And then we're going to select the bottom CV down here and add a cluster to that. Going to name them top CV. Going to call that top CV cluster, and going to name the bottom one bottom. Perfect, beautiful. Now we're going to point constrain the cluster to the controller. So select the controller and the cluster, do a point constraint. Same thing with the bottom, select the controller and the cluster, pressing G again to mimic the last command. And right now you can't see anything because we need to skin this spring to our top control again. Make sure that that's back on closest distance. Bind the skin. And now the spring is controlled entirely by the top controller, which seems like a bad thing at first. But this way, if we pull out from here, it reacts much more like a natural curve, or rather, a natural spring. And that is how you make a spring in two different ways. Press smooth on that so that it looks a little bit nicer. But yeah, that is how you make a joint-based spring rig. And I hope that you found this entertaining and enlightening and helpful. And if these start to get liked more, hopefully I'll do some more. Thank you very much. Have a good day.